Hi, Shana. Good evening. Hi.
Hi,
Happy New Year. How are you doing?
Happy New Year.
Thank you.
I'm doing good. How are you?
I'm doing great, dear. 1 minute, Shana.
So
Just open my.
today,
Yes, today.
okay, um, we can do the 2018 Cayley contest.
Which contest we'll discuss, Shana?
The 2018 Cayley contest.
2018, 1 minute. I think you sent me the one from 2005.
Yeah, those are open response.
Okay, did you send me any mail on 2008? 2018, right? You said?
Yeah,
Did you send any mail?
yeah, it was in the same email.
In the same email, okay.
If there's 2005, and then under that it says 2006.
2018. Oh, yeah. 21, 22, 23, and 24. All right.
So for this one, I tried questions 21, 22, and 23.
Okay.
So like I understood the question and I was able to do something,
Okay.
but I didn't get the right answer when I tried.
Okay. Okay. I'll just share my screen. From question number two. You understood the question number 21, right?
Yeah.
Could you please explain the question number 21 then?
In the diagram, each of P, Q, R, S, T, U, V is to be replaced with 1, 2, 3, so that P, Q, and R are all different. Q, S, T are all different, and R, U, V are all different. What is the maximum possible value of S, T, U, V? Well, S plus T plus U plus V.
All right.
So, they're saying that these three letters are all different, so we have to put three different numbers.
Yeah.
And then this triangle is also all different, and then
UST
this
and
triangle is,
RUV are also different.
yeah. So if we want the maximum possible value for the sum of the last four,
USV. Okay.
then we need to make these two as small as possible, because if this is 3, then these two have to be 2 and 1. So that's not as big as possible. So instead, we can make S, whatever is here, into 1. And then we get 3 and 2. So that's 5. And if we put 2 here, so then if we put 1 here, then we can also get 5. So then the answer should be 10. That's what I did.
Okay. Let's check the algorithm. Okay. Since each of S, T, U, V is equal to 1 of 1, 2, or 3, S and T are different, U and V are different, and their sum cannot be larger than 2 plus 3, 2 plus 3, which is 10. Okay, so they're just trying to substitute S, T, and U, V as 2, 3, 2, 3. Okay. QSTR, QSTR 1, 2, 3 in some order. RUVR 1, 2, 3 in some order. Okay. So if S and T are 2 and 3, then Q is 1. Okay. Similarly, if U and V are 2 and 3, then R is 1. So, but P, Q, R, 1, 2, 3 in some order, and we cannot have Q and R equals to 1. Okay, so what they're saying it like here you have S, T, U, V. You can't reuse the same number again. You cannot have repetitions. So they're saying that if you put like 2, 3, 1 over here, 2, 3, 1 over here, again you might be having two ones on this triangle.
Oh, yeah.
So that might cause a problem because it should be like this, like 1, 2, 3, like 1, 2, 3, right? But in this triangle, if you put 1, 2, 3 for these two triangle, and here you're going to have repetition. You will have
So
Q
then
and
you
R
have to
would
put,
be 1. So you cannot have this option. So which is why they're saying that you shouldn't have S plus T plus U plus V as 10. So you can cut this option. You can cut
so
option E.
instead you have to do 1
We'll try with
and then
9. You can go
2.
according to the option. You can do trial and error. So if you check the next largest possible value, it would be 9. So if you try with 9, what happens? How can you uh, put 9? So if you try 1, 2, 3 in this order, like 1, 2, like anti-clockwise, and for this clockwise, if you try these directions, you might be having, yeah, now you do have three different values for the triangle. So you do have like 1, 2, 3. Here also you do have 1, 2, 3. And for this triangle also you do have non-repetitive value like 1, 2, 3. Like two anti-clockwise and one clockwise you're getting. So if you check this S, T, U, V. 1 plus 3 plus 2 plus 3. It's 5 plus 4, which is 9.
Okay.
So they're saying that 9 is the appropriate options. I have a doubt. Why can't we have 11? Why not 11 is possible? Can you show me? Can
Oh,
you
okay.
try to place the value and show me why 11 is not possible?
So we can't have 3 and 3 in the same row. So we can we have to have different numbers for these 3. So if we put 3 here, we have to put 2 there. Or if we put 3 here, we have to put 2 there. So no matter what, the sum of this maximum can be 5. And the sum of this, same reason. You can't have 3, 3. So the sum of this maximum can be 5. So if, when you add that together, altogether it's 10. So you can't
Yeah.
go bigger than 10 unless you repeat
Yeah.
the
We only
same
have
number.
1, 2, 3. We don't have 4. So there's no chance that you can get 6 by any option. I mean, even if you add all the values, you won't be able to get 11. All right.
Yeah.
Okay. Okay, the next question is about factorial. You know what is factorial, right? You know what
Yeah.
is factorial?
Yeah, I know what factorial is.
Okay. So 5 factorial means it's 5 times 4 times 3 times 2 into 1. It goes up to 1. Okay.
Yeah, so it's
It's
60.
basically n into n minus 1. Okay.
Yeah.
Goes up to 1. Or else you can write 5 factorial as 5 times 4 factorial also. This is also correct. Okay. I think I have seen this question somewhere. Okay. If n is a positive integer, then symbol n factorial represents the product of the integers from 1 to n. For example, 4 factorial is 1 into 2 into 3 into 4. 4 factorial is 24. If x and y are integers and 30 factorial upon 36 power x and 25 power y is equal to an integer, what is the maximum possible value of x plus y?
Yeah.
I think this is a simple one only. We'll just refer the solution. It's very easy. How many cases you are having? It's just Okay. For the given expression to be equal to an integer, each prime factor of the denominator must divide out of the product in the numerator. In other words, each prime number that is a factor of the denominator must occur as a factor at least as many times in the numerator as the denominator. So what they're trying to say is, if you look at the denominator 36 and 25, 36 and 25, their factors can be written as 5 times 5, and for 36 you can write it as 6 times 6, and this will give you 5 square, and for 36 you do have 6 square, right? And 6
Yeah.
can be written as 2 times 3 the whole square, which can be expanded as 2 square into 3 square. So you do have 5 square, 2 square into 3 square. So these factors of the denominator are also the factors of the numerator. The
Yeah.
the factors of the 30 factorial. That's what they're trying to say. So they just
Okay.
expanded it. They just replaced 25 as 5 square, and 25 raised to the power y can be written as 5 power 2y. Similarly, 36 power x can be written as 2 square 3 square raised to the power x. So here in the denominator they have simply replaced 36 power x and 25 power y as 2 raised to the power 2x, 3 raised to the power 2x, and 5 raised to the power 2y. So now you have 2, 3, and 5. So they're saying that these three numbers are the factors of the numerator, factors of the 30 factorial. So if you try to list down all the factors of 30 factorial, if you try to express it through the 5, through the multiples of 5, you're going to have 5 times of 6 will give you 30, 3 times of 10 will give you 30, 15 times of 2 will give you 30, and for 20 also, because it is 30 factorial, 30 factorial can be written as 30 into 29. Somewhere you will have 2 as well, right? So this 30 into 22 will give you 60 also. So 20 is also going to be the factor of the 30 factorial. And for 35, for 25, for 25, again, when you elaborate 30 factorial, you're going to have some answer for the multiples of 20, right? So 20 is
Yeah.
also possible, 25 is also possible, 30 is also possible. So that's what they're trying to say. So each of these factors includes one factor of 5, except for 25, which includes two factors. Okay, what does it mean?
So they're saying that 5, 10, 15, 20, and 30, they all have
Yeah,
5 to the
1
power
into 5,
1
2 into 5,
times
3
something.
into 5, 6 into 5, like that.
Yeah,
But
but
for
then
25, you
25 is
have
5
5
squared.
into 5. So you have two factors, right? So if
Yeah.
you count all the number of 5s, you have 1, 2, 3, 4, 5, 6, and 7 again, if you include the
Yeah.
repetition. So you do have 7 factors of 5. So they're saying that 7 is greater than or equal to 2y. They're comparing these factors with the powers of this.
Yeah.
Okay. So you do have to deal with this 3 and this 2. Yes. So if you try to deal with the 3, they're assuming 3 is lesser than or equal to 3. The product equal to 30 factorial, which includes 10 factors, which are multiples of 3. like 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. 7 of these include exactly one factor of 3. Like 1 3 is 3, 2 3s are 6, 4 3s are 12, 5 3s are 15, and 7 3s are 21, 8 3s are 24, 10 3s are 30. So these 7.
Yeah.
Here what happens, like you do have repetition 3 into 3, and here you do have like 2 into 3 into 3, right? 18 can be expressed like this, and you do have repetition over here as well. And also 27 can be written as like 3 times 3 times 3. You have repetitions here as well.
Yeah.
So you have exactly 2 factors for 9 and 18. You have exactly 3 factors for 27. So you do have 1 factor of 7, 2 factors of 3 for this 9 and 18, and factors of 3 for this 27. So it's 7 into 1, 2 into 2, 1 into 3. So it's 7 plus 4 plus 3, which will give you 7 plus 7. So you're going to have 14 factors of 3. So now you can write 14 is greater than or equal to 2x, because 2x is the corresponding power for the 3. So now you're going to repeat the same for 2 as well. Can you try for 2?
Okay.
1 minute. They're not doing for 2. They did it
So
for 5. Okay, you have 7 greater than or equal to 2y. They did it for 3. You have 14. They're checking for 7 here.
yeah, because
14 can be written as 2 times of 7. And also you have 7 greater than 2y. Oh, okay. I'm sorry. You have 14 greater than or equal to 2x. If you divide both the sides by 2, it will give you 7.
7.
And this greater than or equal to will change into lesser than or equal to. I mean, when you change the sign, like this becomes like this.
Yeah.
Okay, now you can check for 2.
So they're saying that the denominator has, so since if x is 7, the denominator has at most 14 factors of 2. And since the product is equal to 30 factorial, this includes 15 even numbers, 30 divided by 2, which is 15.
2. Yeah.
So the numerator includes at least 15 factors of 2.
Exactly.
So includes more factors of 2 than the denominator. So in the numerator, there's more factors of 2 than there is in the denominator. So they're saying that the number of 2's does not limit the value of x. They mean like, let's say there was not 15 factors. Let's say there was only 5 factors of 2 in the numerator. So now that's a problem, because then you can't have x is equal to 7. You have to have x is equal to 5, because since 2 to the power x and 3 to the power x, they both have to satisfy the equation. So if you want it to be an integer, they have to change it from 7 to 5. But since there's more than threes, there's more twos than threes, they don't need to worry about that. So then it would just be 7 still.
All right. Since x is lesser than or equal to 7 and y is lesser than or equal to 3, then we can say x plus y is lesser than or equal to 7 plus 3, which will give you 10. From that, we can say that is the maximum value can be achieved, which is 7 for x and 3 for y.
Now I get it now. When I did the question, I you're allowed to use calculators. So then I just used a calculator and tried and divided by
Dividing
myself.
the
But that's the way,
factors of 30 factorial.
yeah, and that would take a very long time. So it's not very efficient. I got 13 instead of 10.
Okay. This 3 you got it right. Like how did you, you just have to divide both the side by 2. Since y is an integer, you can include the decimal point as 3.5 and you can round it off to 3. I hope you are able to.
You can have decimals.
Yes. There is also a twist because sometimes when you try to solve a problem, you might be ended up having a decimal value or fraction value. You just have to read the question and confirm that the given value, if the given value is said to be a positive integer, then you have to round off the given, your derived answer to a positive integer.
Yeah.
Okay. A container in the shape of a triangular prism stands on one of its triangular faces. Okay, I hope you're okay. Stands on a triangular faces. Okay. 3 spheres of radius 1 are placed inside the container, each touching the triangular bottom. Each sphere touches 2 of the rectangular faces of the container, and each sphere touches the 2 other spheres. Let me. Okay, hope you're able to see the diagram. 1 minute, I will just. Yes, Shana, I'll just paste it over here and you can relate it.
Okay.
A container in the shape of a triangular prism stands on one of its triangular faces. 3 spheres of radius 1 meter are placed inside the container, each touching the triangular bottom. Okay. Each sphere touches 2 of the other rectangular faces of the container. They are meaning this. Can you follow, Shanna?
Yeah.
So if you take this sphere touches this rectangle and this rectangle. A 4th sphere of radius 1 is placed on the top of the 3. Okay, touching each of the 3 spheres on the top of the prism.
So I understand what we have to imagine. It's like a 3D block and
Yeah.
then it's like this. You're supposed to. So then this side is the bottom. That's where all the circles are.
The fourth sphere must be here, right?
Yeah, the 4th sphere is on top of those. Yeah, and it's touching this side.
Okay. So what is the actual question? They're asking us to find the volume of the prism. Okay. Okay. Okay, so they are breaking this prism into several geometrical shapes. And one is tetrahedron, and another one is triangle. Okay. So we'll be dealing only with the triangle, rectangle, circles, and the tetrahedron. You know what is tetrahedron, right?
Yeah.
Can you draw the can you shade the tetrahedron over the diagram?
Okay. Well, it's not 3D, but the tetrahedron is like all sides are triangles.
Can you see it here? It like the other part is in the back side of the triangles. Yeah. Okay. Okay. Let's go through the solution. So we're going to determine the volume of the prism here. For finding the volume of the prism, we have to calculate the area of its base and height of the prism because it's three-dimensional. So if you
Yeah.
multiply the area of the base and its height, you will get the answer in terms of 3D. So let's calculate the area of its base first. For finding the area of its base, you just have to see the cross section of the prism which is parallel to its base. So they said each of the sphere has radius 1. The triangular cross section will pass through the center of the sphere and points of tangency between the sphere and rectangular faces. Okay. I hope what they're trying to say is you are able to see a circle over here,
Yeah.
and the tangent means the line
They're
which touches
touching the
the
line.
circle at the one point, like it just maintain the point of contact at one point to the circle,
Yeah.
this line. Okay, so this tangency of the circle forms the triangle. So if I draw tangency for this, you'll be getting a single side of a triangle. So if you copy the same, you'll be able to get all the three sides of the triangle. All right. And the rectangular faces, yes. And this one is also. And here also you have. Here also you have. So if you connect all these, you can mark these points as A, B, and C. And
Yeah.
they're mentioning the center of the sphere as X, Y, and Z. And they are also marking the faces of the prism. Faces of the prism, sides of the triangle. Okay. Point of tangency of the sphere to the faces of the prism. So here you do have a point of tangency which is n, and here you do have point of tangency which is n, and here you do have point of tangency which is r, and here you do have point of tangency to the circle which is s. I hope you are able to follow this.
Yeah.
Just give me a second, Shannon. My battery is down. I'll just put it in the charger. Sorry.
Okay.
Yeah. Yes, Shannon. Thank you. I'm back. So now they are joining x to m. Okay, I'll just do it over there. X to m, S2.
Yeah.
Okay, X2MS and X2Y, X2Z and X2A. That. And again, from Y, you're going to join N, B, P, and Z. From Z to Q to C to R. I hope you're able to follow this.
Yeah.
So still we are in the progress of finding the area of its base only. Okay. So for finding the area of the base, you need to know all the side length, right?
Yeah.
And also
Or we can.
it is a symmetry. It is an equilateral one. If you are able to find if you are able to determine the length of the BC, then we can say AB equal to AC equal to BC. You're going to have same value for all the three.
Yeah.
Okay. So now let's find out the value of BC. Okay. YP and ZQ are perpendicular to BC. Okay. Let me highlight the BC. You have BC here. This line YP and ZQ are perpendicular to BC. Since
Yeah.
radii are perpendicular to tangents, we can say that YP ZQ equal to 1. This is the property. This property you need to by heart. When radii perpendicular to tangents, we can say their value is equal to 1. This YP and ZQ is equal to 1.
Yeah.
Because the radius of the circle is equal to 1. From here to here, it is radius, right? This is radius of the circle.
Yeah.
So YP is 1. And ZQ is also a radius of the circle, right? So it's going to be 1. Okay. So if you look at the rectangle, ZYPQ, so it has right angles at P, at Q, and at Z and Y as well. So
Yeah.
we can say that since YP and CQ is equal to 1, ZYPQ is a rectangle. We can say YZ is equal to PQ because in the rectangle, opposite sides are equal, isn't it?
Yeah.
Okay, I hope this point is clear. We'll move to the next point. So the line YZ passes through the point at which the circle touches. Then YZ equals to the sum of the radii of the circles are 2. So they're saying that from here to here, it's 1. And from here to here, it's another 1. So you
Yeah.
can say that YZ is 1 plus 1, right? Which will give you 2. I hope this point is clear.
Yeah.
If YZ is 2, PQ is also equal to YZ. So PQ is also 2 only. I hope it is clear. So PQ is 2. This is 2. Alright. So I've said this earlier that this one is an equilateral triangle. In equilateral triangle, we knew that all the angles of the triangle is 60 degree.
Yeah.
And also you'll be able to notice a line which bisects the ABC into two equal parts. From that we can say This would be 30 degree and this would be 30. Here you have 30 and here you have 30, right? When you put 60 into 2 equal half, you're going to have 30 degree, right? So now they are taking the triangle. 1 minute, let me reduce the line width. I'll just shade the triangle YBP. I hope you're able to see it.
Yeah,
So
I
if you
can
take
see.
this triangle, in the YBP triangle, the angle B is 30 degree, right?
Yeah,
And if you notice, you'll be able to notice a right angle at P, which is 90 degree, right?
yeah,
And B is 30 degree, P is 90 degree. And we knew that sum of all the angles of a triangle is equal to 180 degree. If you substitute the values accordingly, you're going to have the value of y as 60.
yeah. And in a 30, 60, and 90 triangle,
Yeah,
the one side is double the other. Like I
exactly.
forget which side, but something like that.
Yeah, yeah.
And
The
you know
ratio,
that,
the ratio is like that, like 1 is to 2 is to 3.
yeah, and so that YP is 1. So then we can use the ratio to find out what the other two sides is. I just don't know
Exactly.
the ratio.
Exactly. You can use Pythagorean, right?
Yeah. Well, we don't know the two sides. We only know one.
You're just going to use the ratio of the angle for the ratio of their side length because you're having, like 1 is to 2 is to 3 ratio. You can just, if you have the, I mean, the side length is 1 over here, this must be 2.
Yeah, so then this is through
So
square
just
root 3.
4 minus 1 according to the Pythagorean principle, you're gonna have square root of 3 for BP. Yashana?
Yeah. So then if this is square root 3, then QC is also square root 3.
3,
So then
exactly.
all
They are
together,
symmetry. They are symmetry.
it's 2 plus 2 square root 3.
It's root 3 plus 2 plus root 3. So it's 2 root 3 plus 2, which will give you
Yeah.
2 plus 2 root 3. So that's going to be the side length for the BC. If BC is going to be 2 plus 2 root 3, then AB and AC is also going to be 2 plus 2 root 3. Is it clear?
Yeah. And now I know how to solve the height.
Exactly. So we solve the area of the base. We can move on to the. Oh, we are not done yet. We also have to calculate the area of the triangle
Yeah,
ABC.
like I mean the height of the triangle.
Yes, yes, because it's going to be half into base into height, right? So they're drawing a line which is perpendicular to the BC. That line is going to be 80. So we knew that 80 can be written as root 3 by 2 times of AB. And we know the value of AB. AB is nothing but it's just 2 plus 2 root 3. So it's root 3 by 2 into 2 plus 2 root 3. That's going to be your 80. We know the formula for the triangle, which is half into base into height. So if you substitute the value of half and the area of the base and the height, you simplify it, you're going to have half times root 3 by 2 will give you root 3 upon 4.